2 years ago, I was honored to present live at this conference, and I talked about how Passive House should be all about health and comfort, and that this would be increasingly important in the near future. I've been discussing how we went from living like this with clutter and all of this stuff around us to, in just 25 years after that, aspiring to this. And the reason was this, that after World War I, the world was suffering from the after effects of tuberculosis and the influenza that killed millions of people. Florence Nightingale, 40 years earlier in the Crimean War, had finally put together that cleanliness and fresh air reduced disease significantly. She thought disease was carried by the miasma, that it was carried in bad air. Then Robert Koch and Louis Pasteur explained germ theory, that it wasn't just bad air, but the stuff that was carried in air, in water, and on surfaces. Architects started cluing into this, and this is how we got modernism. Buildings that were full of sunlight and fresh air and that were easy to keep clean. Started with tuberculosis sanitarium, like Aalto in Finland, setting an example here, where all the furniture was tubular and easy to clean, or plywood that could be just wiped down. And architects learned from this. In particular, the first of these houses were designed for doctors, like the Lovell Health House, or the Maison de Verre, which was designed for a gynecologist, where every surface in the house was washable. And of course, the Villa Savoye up on stilts to keep it away from the dirt, which Le Corbusier thought was filthy. Everybody is appalled by the radiant city proposed by Corb, but in fact, at the time, there were serious plans for demolishing most of Paris because nobody had toilets and everybody was crowded together, and it was all about health and air. Then penicillin came along. It killed all these bugs. We brought vaccines for tuberculosis and polio, and the diseases that terrorized our cities were beaten in most of the developed world. When I spoke here 2 years ago, I was concerned about the upcoming antibiotic resistance and how we had to start thinking about building like we did before we had antibiotics. And I said Passive House should be the healthy house, that we should own this sector with its sealed walls and its filtered fresh air and its insulation that in colder climates made it possible to get decent humidity without condensation. And now we have this, the coronavirus. No vaccines, well, maybe a vaccine was just announced. And it's more important than ever that Passive House be placed in this sector as the healthy house. Now, this has been controversial for the last couple of months because all of the doctors and all of the people at the various health agencies have been working on information that goes back to the 1930s, that flu and tuberculosis and viruses are carried on droplets by touching stuff where the droplets fall, which is why you've got to be able to wash everything, and where the 2-meter rule came from. Back there, from the sky, William Wells in 1934. Or in Canada, we have to stay 1 moose apart. But even back in March, the building science people, the people who knew about how air moves, started suggesting that there was more to it and we should be considering other factors. I wrote back in March that ventilation is critical. Another point is that in a Passive House building, the interior air is not filtered and recirculated as it is in normal homes and offices. It is exhausted and replaced with fresh outside air through the heat recovery ventilator. In around April, the European engineers started recommending that we should stop recirculating buildings at all, recirculating air in buildings at all, and calling for what they called hygiene ventilation. Architect Justin Beer wrote from London that COVID-19 should be a wake-up call for the building industry, for governments and for statutory regulators of the construction industry. It's only when building heat load is very small, as it is in a Passive House building, that hygiene ventilation is possible at all. Now, I should explain that in North America, nobody has radiators and everybody has forced air that is recirculated. The air carries the heating and the cooling, and it also gives you some fresh air. And so the problem is much worse than it is in Europe, where they do not have constant recirculating air systems to the same degree. And more research was being done that this recirculating of air was really terrible. And scientists were saying all precautions possible should be taken against airborne transmission in indoor spaces. That includes increasing the ventilation rate, using natural ventilation, and avoiding air recirculation. In America in particular, this is almost impossible. You get into a really hot climate and they're recirculating 85, 90% of the air, and suddenly they're being asked to bring in 100% of air. Well, they didn't. They couldn't, because the systems aren't designed that way. By July, researchers and building scientists were demanding that the World Health Organization start accepting that this is happening, that it's being carried as an aerosol and not as droplets. And they started getting really noisy, but it was more and more clear that it's carried on respiratory droplets less than 100 micrometers. And it's like less like stuff that falls to the ground and more like cigarette smoke. If somebody's on the other side of the room, you smell that smoke. It moves and fills the whole room. It was also controversial. In the United States, it wasn't until September where the Center for Disease Control finally admitted that it could travel as an aerosol. And I thought this was going to be really, really significant. Trump was the president, and basically I said, you don't want to go to a Trump rally or any other crowded, poorly ventilated indoor space where people aren't wearing masks. This doesn't bode well for the restaurant industry, where people are close together, and it raises many questions about the kids going back to school. Well, this was evidently too controversial because they actually pulled this 3 days later and went back to the old advice. And finally, on October 6th, they agreed there might be something, but they were so wishy-washy about it and said, there is evidence that under certain conditions, people with COVID-19 seem to have infected others more than 6 feet away. In the last couple of weeks, the building scientists have been getting really upset and demanding that the WHO change their approach. They've been putting out this petition that's, I think, now up to 8,000 signatures. We, citizens of the world, request the WHO recognize the compelling scientific evidence that SARS spreads by aerosol transmission. Robert Bean, who is an expert on passivhaus ventilation, and that is one of the people who just on the 5th of November was saying, what, not one building engineer on the WHO team? What does society call a professional who practices in a field they're not qualified to practice in? Unethical. They're really upset that they don't have the right people looking at this. And even just last week, people are writing, understanding aerosol transmission could be key to controlling coronavirus. And just last week, the Prime Minister of Canada finally recognized that there's increasing evidence that aerosol spread is a vector of transmission. And this is where Passivhaus shines. This is where we have been and can be and will be. They've been saying this all along. As Courtney Rodney Brown wrote in this article back in August, hygiene ventilation focuses on using 100% fresh air to ensure the viruses are not recirculated in enclosed areas, whether commercial buildings or homes. Passivhaus presents itself as the environmentally and economically sustainable option, one that has been employing hygiene ventilation as one of its basic tenets in the form of balanced ventilation. Jonathan Cairns, an architect of many passivhouses, including this beautiful passivhaus renovation you see here, his firm wrote that Passivhaus presents a wonderful opportunity to build better, create healthy environments, to future-proof our buildings. The standard has the ability to respond to COVID-19 while not ignoring climate change, as the systems it employs allow for total building design where environments are healthy, energy is saved, and emissions are avoided. And Dr. Feist, one of the co-founders of Passivhaus, he pitched in this too. To explain, a ventilation system with heat recovery brings fresh, hygienically clean air into the home. This is not recirculated air, which has been the cause of concern to some. Systems certified for Passivhaus have good filters, which significantly reduces germs more than a conventional mask. Passivhaus buildings are good for health, he said. Now, it's not just the air ventilation system where Passivhaus becomes so important. There are many other factors involved as well. And we have to start rethinking the way we design our houses themselves to be more suitable for living in a world with COVID-19, which has changed the way a lot of us have lived. Consultant Susan Shelton has said that we now want to have separate rooms, the doors that can close. The open plan is in trouble. We want dedicated spaces for homeschooling. We want pantries and storage for the food that we're buying in bulk. And I've made the case many times, and never more important than now, that we have to rethink the way that we design our kitchens. You know, in Germany back in the 30s, everybody lived in one room, and they thought this was a terrible thing and it had to change. And we know that urban air pollution makes COVID-19 even more deadly. There have been significant links between the pollution and the rate of the disease. And yet when we design our kitchens, we've all, even in Passivhauses, been designing them in ways that increase internal air pollution. This study was actually done in Passivhauses. None of the Passivhauses had range hoods that exhausted directly to the outdoors and instead were recirculating. This strategy did not prove to be effective. The particulate emissions from cooking overwhelmed any exhaust removal and spread to the rest of the house, and concentrations remained high for several hours. And in America in particular, this is how everybody is designing their houses. You know, everybody's spending all of their time around the kitchen table. Kids bring their school books and their bags from outside in, and everything gets dragged into the kitchen where people are trying to cook as well. It was the American fantasy in the 1950s and the 1960s. And it still is, where everybody's putting in giant gas stoves with no proper ventilation. In Europe, on the other hand, after that German scene, they just started developing the Frankfurt kitchen, where Marguerite Schutt-Lisowski proposed that it all be one very small space, that you go in, you do your work, and then you go out and live your lives, and that it's all designed almost like a hospital room so that everything can be cleaned. And there were lots of them. But it's not what people seem to want. They want to fill their whole place with all these pollution and PM 2.5 that comes off cooking in gas stoves. In China, where you have to have the kitchen enclosed because of the flash cooking that they do, they actually are now selling kitchens where it looks like a Western kitchen. The counter might run right through the glass, but they're enclosing the whole thing in glass so that they can get proper separation of ventilation. We have to start thinking like this in Passivhauses again. We also have to think about our bathrooms. There's a reason Le Corbusier put the sink in the hall, so that everybody who comes home can actually wash their hands before they do anything else. Even in one of the most luxurious houses ever built at the time, this was the principle that was in play. When I used to work in real estate development, every house that our company sold, not in prefab houses, every house that the company sold had this arrangement where people would come in through the garage into a room which had the laundry and a bathroom. And being from the city, I asked the owner of the company why, and he said, they're farmers and they're workers. They want to come in, they want to drop their dirty clothes in the laundry, change, wash up, and then grab a beer. It's the sequence of how they live. Meanwhile, in Philadelphia, the architects of a project called the Onion Flats were looking at their plans, this was before the virus, and redesigning their bathrooms in a way that turned out to be really incredibly ingenious. To save space, they did this to save space, but then the virus hit and they realized what they had. That basically the vestibule, when you come in this little apartment, is the bathroom. You can close off the door to the rest of the apartment, and you've got a two-piece here, and you've got a shower there, you've got the laundry machine opposite, and a closet. With this setup, they not only got more space, but they basically had a way that you could live in an apartment exactly like those people did in that country house, where you come in and your entry vestibule is your bathroom. And it's quite attractive. And you've got the shower is hidden behind that door when it's open. And when that door is closed, the place becomes a bathroom. At the whole other end of the scale, this is work by Andres Duaney for very expensive apartments in Florida, where you can see their outdoor corridors, which are more expensive, which is because that's why they're out of fashion now. But it's back to the single loaded outside corridor, a big space in front of the front door, which is like a outdoor sitting area. When you enter, it's through that intermediate zone, an entry vestibule that you can go right into a cleanup room. You can change your clothes, you can wash your hands, you can go to the bathroom before you even come into your house. And then up at the top, there's a flex space, which is a room that opens directly to the outside so that it could be your home office, where you could meet people from the outside, or other uses where you want that ability to meet people and not have them come into your house. On the second floor, there's a special bedroom with its own door to the outside as well, to the stairwell, so that if somebody in your house is sick and you've got medical help staying with you, there is a room that they can be in. Finally, we have to start thinking again differently about materials. I mean, back in the 50s, they proposed that one day our home would be waterproof and that the housewife of 2000 could do her daily cleaning with a hose. It's not a bad idea. A French architect, Charlotte Taylor, worked with a German renderer to do these wonderful images of an entire apartment that is basically floor to ceiling tile. Even the furniture, even the couches are sort of built-in tile. And the bed, built-in tile. It's a bit much, but you get the sense that here's a whole house that pick up the cushions and you could clean it with a hose. Americans used a ton of vinyl. This is in the 60s because vinyl was easy to clean, but vinyl is virtually a solid fossil fuel with high embodied energy, and it releases phthalates, these chemicals that are endocrine disruptors, and so nobody wants to use vinyl anymore. But there are many different materials. In my own house, I just used painted concrete on the floor. Italian companies are producing, and Chinese companies now, these wonderful sheets of porcelain that cover the whole wall without a grout joint. And different materials have antibacterial properties. The front door of my old house was wood, which is antibacterial, and brass. They made everything out of brass and copper for years. One of the main reasons was it was known to be antibacterial. I put on a copper plate for my push plate, and then recently put on a stainless doorknob. Pretty stupid thing to do now that I know what I know, but I'm not changing it now. Marmoleum from Germany is antibacterial and totally healthy material, all made from jute and linseed oil. And then there's my favorite material, of course, cork from Portugal. I fell in love with it 2 years ago, and it really is my favorite now. And it can be used obviously for floors and walls and anywhere now. Back to Susan Shelton again, who was noting that our needs have changed. What we're worried about has changed. In her survey, she found it's clear that in America anyway, people are less worried about those higher levels of those old Maslow pyramid, and they're more worried about the basic safety and psychological needs. The two top worries we have by far are health of the economy and disease outbreaks. And health and safety are going to be a very big deal for quite a while now. That's why I'm going to end with this slide again from Cairns Mancini that lists the virtues of Passive House and why I think it's so important to promote ourselves as the healthy solution. It's obviously got, as we've discussed, a healthy environment, a good ventilation system that removes most of the allergens and also brings you continuous fresh air. Enhanced comfort, no temperature swings. Wellness, we should be eliminating toxins, continuous and consistent temperatures for an overall improvement in wellness. In colder countries than Portugal, this is a very big issue of controlling humidity. You can't get the humidity up to where you want it, to between 40 and 60%, when you've got moisture condensing on your windows and mold forming on your walls. Energy efficiency, the building does more than well, that one everybody has talked about, uses very little energy. It's resilient. The building maintains a constant temperature, which results in a resilience to extreme weather and periods of no power. And it's affordable, which we know, in well done, it can be no more expensive than conventional buildings. So thank you very much.